Okay, for Chapter 5 you won't have to turn anything in. This is just a review of the problems that I gave you in class last week. Okay, for our indirect proof here, remember we're always going to start with an either or statement. So, first step here in our paragraph proof, either angle ABC is congruent to angle DCB, or angle ABC is not congruent to angle DCB. Remember, I always get that either or from what I'm trying to prove. And then of course we are going to assume the opposite of what we are trying to prove. We're going to assume angle ABC is congruent to angle DCB, and of course I'm going to mark that in my diagram just like I would for any other proof. Now I'm going to look at the given information and I see that AB and DC are congruent line segments. So I'm going to go ahead and continue on here. Since AB is congruent to DC by given, of course mark it, and BC is congruent to itself by the reflexive property, we know triangle ABC is congruent to triangle DCB by side angle side. Now, why does it help us? Looking at the second piece of given information, we see that line segment AC is not congruent to line segment DB. We are going to try to contradict that information, which we now can. Since we proved triangles are congruent, we know for a fact that line segment AC and line segment BD are congruent by CPC-TC. So I'm going to say in my proof, by CPC-TC, AC is congruent to line segment BD. However, given states AC is not congruent to BD. Exactly what we want, a contradiction. Two things that are impossible to exist at the same time. Two line segments cannot be congruent and not congruent at the same time. It is impossible. Therefore, therefore, our only other possibility is that ABC is not congruent to angle DCB. And we are done. Okay, the next questions deal with parallelograms. We need to know two facts for this particular set of problems. And these two problems are actually, I want you to treat them independently of one another. They're each separate problems, left and right. So the problem on the left, we see angle A is given as 3x plus 20 degrees, angle D, 8x minus 5 degrees. And we're looking for angle A in both figures. So the one fact that we need to know is that consecutive angles in parallelograms are supplementary, which of course means 3x plus 20 plus 8x minus 5 is equal to 180 degrees. We'll then combine like terms. 11x plus 15 equals 180. Subtract 15 from both sides, and 11x is going to equal 165. Divide both sides by 11 to get our x value. So we'll take 165, divide it by 11, that goes in there once, 55 left over, so 15 is going to be our x value. And of course, when I plug that in for angle A, I'm simply going to take 3 times 15 plus 20, which is 45 plus 20, 65 degrees for our first answer. Second problem, since we know opposite sides of a parallelogram are parallel, we know that alternate interior angles are congruent. So we're going to set up x squared equals 13x, subtract 13x from both sides to set our equation equals 0, factor out an x times x minus 13 equals 0. Therefore, our x values are 0, or positive 13. Now, when we plug these values in, of course, 0 is not going to work because an angle can't be 0 degrees. So therefore, we're going to try 13. Angle A is, of course, 13 times 13, which gives us 169 degrees. Doesn't quite look that big. However, the algebra tells us the answer is, in fact, 169 degrees. This particular proof is fairly complicated. There's a lot going on here. So I'm going to leave out the first two givens because I actually won't use that until the end. So let's start with angle 1 congruent to angle 2, which is given. It's a hideous looking given, but I'm going to mark that in my diagram, and that will tell me a couple of things. First off, it will tell me angle 3 is congruent to angle 4 because angles supplementary to congruent angles are congruent. And the other thing that'll actually tell me is that line AC and line DF are parallel. So that's step 2. Step 3 will be AC parallel to DF. Because if alt int angles congruent, then parallel lines. Again, my alternate interior angles are 1 and 2. Next step, I'm going to throw a 5 and a 6 in. 5 and 6 are congruent because they are vertical angles. So angle 5 congruent to angle 6, vertical angles. And then, of course, our other given piece of information, BG congruent to GE, right above there, I'm just going to throw into step 1. Why not? Getting a little messy here. But what that does, BG congruent to EG, is it gives us congruent triangles. My figure's, like I said, a little bit messy, but hopefully you can see we have an angle, a side, and an angle that gives us triangle DEG congruent to triangle CBG. And like we said, angle, side, angle. Now here is where our first two pieces of given information that we haven't used yet, here's where they come into play. We can now say line segment BC is congruent to line segment DE because of CPCTC, DE, BC, and now I'm going to use my givens. B and E are midpoints of AC and DF. Now we haven't seen this for a while, but what you should know is that now line segment AC is congruent to line segment DF by multiplication. If you're not following that, you need to go back and review multiplication. And then, of course, number 9 is our proof step. ACFD is a parallelogram, and the reason being one pair opposite sides of our quadrilateral are parallel and congruent. Complicated proof, and actually that proof can probably be done, I know at least one other way, maybe a couple other ways with a couple different types of steps, but for the most part, this is how you would perform the proof. In this problem, the book I believe calls this a crook problem. I don't know why, but it doesn't matter. And the book will actually show you a different method of solving this than I will show you. However, what I like to do here is extend a line segment like so in order for us to have a couple of things going on. For starters, alternate interior angles are congruent because of these parallel lines, and extending that line also gives me two triangles. I have a triangle here, and I have a triangle up here. And we already know for a fact that triangles contain 180 degrees, so that's going to be really key in this problem. We need to know about supplementary angles, and we need to know that triangles have 180 degrees, coupled along with the fact that alternate interior angles are congruent. So I'm going to start at the bottom. The angle here that I'm drawing a gray arrow to is the supplement of 50. It's 130 degrees. So what I know is that in the triangle that I redrew in red, I have a 130 degree angle and a 20 degree angle, which adds up to 150, which tells me, I'm going to use another arrow here, that angle is 30 degrees. Well, if that angle is 30 degrees, this angle up above must also be 30 degrees. Again, parallel lines and alt-int angles congruent. Arrow to 40 degrees. Why? Because it's a supplement of 140. 40 and 140 are supplements. So I have a 40 degree angle plus a 30 degree angle. That gives me 70. Another arrow to that angle would be 110. So X is the supplement of 110. It is in fact 70 degrees. On to our next proof. Here we have an example of overlapping triangles once again, and the given information tells us that AB is congruent to CD. But what you should notice is that the triangles that we are comparing, hopefully you realize that would be triangle ACG, which I've outlined in orange, and BDE, which I'm outlining in blue. Probably not the best color to choose, but that's all right. Those are the two triangles I am comparing. Now, AB and CD are not long enough. In other words, AB doesn't cover the entire top of our triangle. We have to go all the way to BC. So our first step is to say AC is congruent to BD by addition. Now, I have the tops congruent, and I'm not sure why. That should be our second step. Shockingly enough, I forgot to put our givens in. So let me do that real quick. Step 1, I'm just going to put it up here. You guys can make yours more neat and organized. AB is congruent to CD. That's step 1, that's given. And then of course I have my addition. Step 3, AG is congruent to BE. That's also given. Perfect. AG and BE. And what you've noticed now is I have two sides of my triangles congruent. The top and the left, and the top and left. So my next goal here is to prove angle 1 is congruent to angle 2. Now I can do that using my third piece of information that is given. AG is parallel to BE. I'm just going to add that into step 3, which tells me angle 1 is congruent to angle 2. Why? If parallel lines, then corresponding angles are congruent. Now, as you can clearly see, hopefully in my diagram, triangle ACG is congruent to triangle BDE. Side angle side. CPCTC tells us angle 3 is congruent to angle 4, which leads to our proof step, GC parallel to ED, segments parallel. Why? Because if corresponding angles congruent, and 3 and 4, those are our corresponding angles, then we have parallel lines. I really like this proof. It's an interesting proof just for the fact that we use two theorems that are opposites of one another. So it's really important that you write those theorems correctly. This next problem, again, determines whether or not you understand slope. And what we need to do in this problem is find the slope of all four sides of this quadrilateral. So we're just going to plug all of our coordinates in to find slope for each of the four sides. And we're going to start with the top side, 7 minus 4 over negative 9 minus 11, which is going to give me 3 over negative 20. That's my first slope. My second slope is going to be found by taking 4 minus a negative 6 over 11 minus 7, which is, of course, 10 over 4, which reduces to 5 halves. Bottom is going to be negative 3 minus a negative 6 over negative 13 minus 7. Minus negative 6 is, of course, going to be taking a positive 6 minus 3, which is 3 over negative 20. That would be that line. And then my last slope is 7 minus a negative 3 over a negative 9 minus a negative 13, which is going to be 10 over positive 4, which is, of course, 5 halves. So, to answer our questions, and I will say this, a lot of people on quizzes and tests have really given me poor explanations as to whether or not we have a parallelogram or a rectangle based on slope. It's actually a really simple explanation. The answer to part A, is it a parallelogram? Yes. Why? Here's why. The left and the right side are parallel because they have the same slope. The top and the bottom are also parallel because they have the same slope, 3 over negative 20. So you just have to put that into your own words. And of course, you know parallelograms are quadrilaterals whose opposite sides are parallel. Question B. Again, it's also a very simple explanation. Is it a rectangle? The answer is no. Why? Because in order for a parallelogram to be a rectangle, it has to have right angles. And this angle, along with the other three in this quadrilateral, aka four-sided figure, are not right angles. Reason being, 3 over negative 20 and 5 halves, in other words, the slope of the top line and the right line, are not opposite reciprocals. Therefore, it is not perpendicular, not a right angle, so we know it is not a rectangle. It is a parallelogram, but not a rectangle. Find the perimeter of the isosceles trapezoid. Okay, 2 facts you need to know. Step 1, fact 1, the 2 legs of an isosceles trapezoid are congruent. So I'm going to label the right side X. The second thing you need to know is that the lower base angle and the upper base angle are supplementary. Therefore, 4x plus 6 plus 12x minus 18 is going to add up to 180 degrees. So when I combine like terms, 16x minus 12 is going to equal 180. Add 12 to both sides. And we know that 16x equals 192. So we're going to divide both sides by 16, and x is going to equal, when I do the math, 12. So the question says for us to find the perimeter. So I'm simply going to plug in 12 for x. 2 times 12 on bottom, that side is going to be 24. This leg is going to be 12. This leg is also going to be 12. And the top is going to be 12 plus 3, which is 15. Simply a matter of adding those 4 numbers up. 24 plus 12 is 36, plus another 12 is 48, plus 15 is 63. So our perimeter is 63 units. I may have saved the easiest problem for last. Hopefully you feel that way. This problem, find the perimeter of the parallelogram, is pretty straightforward. 4x plus 8 is our top. BC is 2x plus 4, and then CD is 6x minus 2. And you guys know opposite sides of parallelograms are congruent. Therefore, 4x plus 8 equals 6x minus 2. And when we do the math, 2x equals 10, x equals 5. We simply plug in our x value of 5, and we get 2 times 5 plus 4, not 14, 4, which is 14 for BC and AD. Opposite sides, of course, are equal. And then when we plug in 5 on the bottom, 6 times 5 is 30. 30 minus 2 is 28. Top and bottom are both 28. To find the perimeter, I'm simply going to add up all 4 sides, and that's going to give me 84 units. And that concludes our semester exam. Keep studying. Do well. Merry Christmas.